Good morning, students. Today I am going to give you a lecture on the topic that is features of object-oriented programming system. The features of object-oriented programming system are categorized as follows. The first one is polymorphism, the second one is encapsulation, the third one is inheritance, and the fourth one is abstraction. I will give you the detailed explanation of all these features one by one. So today, let's start with polymorphism. The word polymorphism is made up of two words, that is poly and morph. Poly means many and morph means form. So polymorphism means many form. We can find many examples of polymorphism in our daily life. One common example is the cell phone. This is because a cell phone can perform many jobs like phone, camera, and music player. So in this way, a cell phone can behave in the form of a phone. A cell phone can also behave in the form of a camera, as well as a cell phone can behave in the form of a music player. So it is the same cell phone which behaves differently. Now polymorphism is of two types, the static polymorphism and the dynamic polymorphism. The static polymorphism is implemented with the help of method overloading, whereas the dynamic polymorphism is implemented with the help of abstract classes in Java. Now the topic for discussion today will be the static polymorphism, and the static polymorphism will be implemented with the help of method overloading. Okay. Now let's come to know what is method overloading, as polymorphism is implemented with the help of method overloading. Now when I am referring to polymorphism, you should keep in mind that currently I will be discussing about static polymorphism, because it is this polymorphism which is implemented with the help of method overloading. Method overloading is the concept of defining more than one method with the same name but different signatures. And signature of a method consists of number of arguments a method takes, its order and its type. Now I am going to show you a Java program to calculate the sum of two integers or two floating point numbers using the concept of method overloading. So this is the program, and this program is specified by the class name known as calculator. Now the opening brace of this class calculator and the closing brace of this class calculator signifies the scope of the class or the body of the class. Now inside the body of this class, you have two member methods. This is the first member method, and this is the second member method. And both these member methods are having the same name, that is sum. But even though both these methods have the same name sum, still they have different signatures. Now see, the signature of a method consists of the number of arguments a method takes and then its order and type. Now if you see this program, both these member methods denoted by the same name, that is sum, contains two arguments, that is a and b. The first member method contains two arguments a and b, as well as the second member method also contains two arguments, that is a and b. However, their signatures are different. This is because the data types of those arguments for both these methods are different. For the first method sum, the data types of the arguments a and b are both int, or they are of integer type. Whereas for the second method sum, the data types of the arguments a and b are both float, or we can say that they are of floating point type. Since the data types of the arguments for the first method sum is int, that's why the arguments can accept only integer type values. Whereas for the second method sum, since the data type of its arguments a and b are both of type float, that's why these arguments a and b can accept only decimal values. So both these methods, even though they hold the same name, they have different signatures. And so this property is called as method overloading. Now in addition to these two methods, this program specified by the class name calculator also consists of another method known as the main method. The main method is represented using the statement that is public static void main, and inside its parenthesis it has one argument, that is args of type string, and there are three action statements inside this main method. So these are the three action statements, and all these three action statements exist inside the body of this main method. This is the opening parenthesis of the main method, and this is the closing parenthesis of the main method. The opening parenthesis and the closing parenthesis of the main method signifies the body of this main method, or the scope of this main method. Just as how your class has a body represented by the opening parenthesis and your closing parenthesis. But something is missing in this class, which is specified by the name calculator. So can you guess what is missing? See, this class specified by the name calculator consists of two methods. These two methods bears the same name, but they have different signatures, and this property, as I said, is called as method overloading. And in addition to these methods, they have the main method, which is the point of execution of the Java program. Now what's missing in this program is the data members section. Now, unlike in my earlier presentation where I have shown you a program in Java that creates a class by the name cake, this class consisted of three different sections. The first section was the data members section. The second section was declaring the constructors, and the third section was declaring the member method, and lastly they have declared the main method. Now see, this data member section is optional. Depending upon the needs of the user, he may or he may not declare data members for a class. Since this program requires data members to be declared, that's why at the very beginning the data members weight and flavor were declared of type float and string respectively. And the values for these data members weight and flavor are assigned inside the constructors. So these constructors were used for initializing the data members of this class. Now the purpose of this program is to calculate the sum of two integer or two floating point numbers using the concept of method overloading. Now this can be done without the declaration of data members. Now I can show you from this program how you can calculate the sum of two integer numbers and the sum of two floating point numbers without declaring the data members for this class named calculator. And this can be achieved with the property called method overloading. So these two methods bearing the same name sum but different signatures will help you calculate the sum of two integer numbers and the sum of two floating point numbers. Now remember that floating point numbers represent the decimal numbers. Now as the point of execution for a program starts from the main method, so let's start with the main method, execute this statement and come inside. The first statement inside the body of the main method is calculator C equal to new calculator. So this statement creates an object by the name C of the class called calculator. Usually when an object is created for a class, the constructors for that class are called. But since this class denoted by the name calculator does not have any constructors, so there is no question of calling any constructors upon the creation of this object called C. Now come to the next statement, that is system.out.println. Then inside the parenthesis, with the help of this object called C, it is calling the method sum using the dot operator. And when it calls the method called sum, it takes two arguments or two parameters. The first argument is 10 and the second argument is 20. Now see, both these numbers 10 and 20 are the integer numbers. So when the object C calls this method sum containing these two arguments 10 and 20, so which method out of these two bearing the same name sum gets called by this object C? Since the arguments contain only integer values which are 10 and 20, so the first method sum will get executed, as both its arguments A and B are of type integer. So when the first argument is 10, when the object C calls the method sum, then for this method with the name sum, 10 will be passed to the first argument a. So a will now contain the value 10. So let me write 10 here to represent the value of a. And the second argument 20 will be for b. So 20 represents the value of the second argument b for this method sum. Now just come inside this body of this method sum and execute the action statement represented by return a plus b. So when the action statement return a plus b gets executed, then with a having the value 10 and b having the value 20, the value of a plus b will become 10 plus 20, which is 30. So let me represent the value of a plus b as 30. So this value of a plus b, which is 30, okay, this value of a plus b, which is 30, will be returned using the return statement from this method called sum. And since 30 is an integer, so the return type of this method sum is also denoted as int. Now once this value 30 gets returned by this method sum, it will be returned to this print statement. So the value of the object c when it calls the method sum having two arguments 10, 20 is 30. So the first print statement, that is system.out.println, prints the value 30 in the output. That's why in the output you can see the first value as 30. Now that these values are only for you to understand, so I'm going to erase these values now. Now after this statement gets executed, come to the next action statement, which prints c.sum having two arguments 9.5, 20.5. So even in this case, the object c that was created for this class called calculator will call the method, and with two arguments 9.5 and 20.5, which are clearly the decimal values, it is going to call the second sum method, not the first one. This is because only in the second sum method the type of its arguments are float, which represent decimal values. Now when the first argument is 9.5, for this second method sum, a will get the value of 9.5, and similarly b will get the value of 20.5. Now come inside this method, that is inside the body of this method, execute this action statement, which is return a plus b. This action statement will return the value of a plus b, which will be 9.5 plus 20.5. Now you calculate what is 9.5 plus 20.5. If you calculate 9.5 plus 20.5, the result will be 30.0. Okay, the result will be 30.0. So the value of a plus b will be 30.0, and this value will get returned with the help of this return statement from this second method bearing the name sum. And since this method sum returns a decimal value, that is 30.0, that's why the return type of this method sum is also float. Now once this value 30.0 gets returned with the help of this return statement from this method sum, this value gets passed onto this print statement. That is, it gets passed onto here. So when the object C for this class called calculator calls the method sum having the arguments 9.5 and 20.5, the value that gets returned is 30.0, and this is the value that gets printed with the help of this print statement. So that's why in the second output statement you can see the value 30.0 getting printed, and this value, which is 30.0, gets printed from this statement using system.out.println, where the value of c.sum with arguments 9.5 and 20.5 is 30.0. Now, as I have shown you the output for this program, I am going to delete these values because these were only for you to understand. So that's the end of this program. So in this program we have learned that the method sum exists in different forms. First, in this form, and secondly in this form. In its first form, okay, that means in this form it takes two integer arguments which are a and b, and in its second form, that is in this form, it also takes two arguments, but they are not integer arguments as in its first form. They are of floating point arguments which accepts only decimal values. So these two methods have different signatures, and this property is called as method overloading. And this type of method overloading implements static polymorphism.